welcome to Podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports us on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at www.podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app or experimenting with something that you hear about on the show. You can visit the site at www.podcastinit.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host as usual is Tobias Macey, and today I'm interviewing Darin Gordon about Yosai, a security framework for Python applications. So Darin, could you please introduce yourself?
Hey everyone, it's an honor to be here and to speak before such a great audience. I've been working with Python for almost 4 years now. I do have a tech background, but working in financial services for almost 10 years, I went from a programmer position into something in product development and risk management and margin financing and prime brokerage. So I've done a variety of things, and I'm back working again full time as with programming for my own venture, and I wanted to give back by working on the Yosai project, and so I'm really happy to be here today and to tell everyone more about the project.
And do you remember how you first got introduced to Python?
Well, for me, it was a strategic decision. 4 years ago, I had an important decision to make. What language will I use as my primary language to build at least the first version of the services for my venture? I'm doing something entrepreneurial. So I consider Java, Ruby, Node.js, and Python won because basically with Python you can go further. It's a powerful general purpose language. I can use it to create services, and I can use it for analysis. It's a really powerful analytical tool. It's got a great diverse ecosystem of open source projects that I could adopt for my work. I can optimize it and extend it to run quickly. And I'd say the most important reason why I chose Python is because there's just a huge global community of people who love to use the language. They're passionate about it, and they're willing to help other people like me use it better. So I've gotten a lot of help along the way because of that. And again, I felt indebted to somehow find a way to give back, and I'm trying to do that now with this work.
And so that's a good opportunity to describe a bit about what Yosai is and the problem that you're trying to solve when you first started it.
Sure. So Yosai, it began as a proprietary project, for internal use. But I decided to open source this project. I'm working on a venture now where application security it's a top priority. Once I decided that I'd use an authorization policy based on role-based access control, I looked for an open source solution written in Python that I could adopt to enforce RBAC. The problem is no such library really existed in Python, but I did find one in Java. It's called Apache Shiro. Now, the problem is I didn't want to use Java in my work. I wanted to use primarily Python. And I didn't want to extend Python with this library. So I figured, why not port Apache Shiro to Python? And so I did. And the result is Yosai. Yosai is a security framework written in Python that is based on a version 2 alpha implementation of Apache Shiro, which is written in Java. It offers authentication, authorization, and session management from a common API. In other words, Yosai helps a developer verify who a user claims to be. It helps the developer control what the user can do in the system. And it helps you set time limits on how long a user may use the system or idle for before requiring that user to re-verify its identity. Aside from just those 3 core services, some other features I'd like to highlight are two-factor authentication using time-based one-time passwords. You can throttle authentication attempts, locking accounts after a certain number of failures. Yosai produces a full audit trail of every major event that's happened through the system, structuring, and it's producing it through structured logs, formatted as JSON, and with that it could be analyzed further downstream by other systems. And another really useful feature is the user impersonation tool, which is for administration use, where a developer or an admin of some type in operations would be able to perform activities in the system as if they were that user. all of this was really compelling for me. I found it worthwhile to build Yosai.
And so you mentioned that when you were first sort of auditing the available libraries to fulfill the need for having that role-based access control, that you didn't find anything that suited it. So I know that at least in the web arena, there are things like Flask Security and Django Guardian that have a fairly granular capability for permission control. But it sounds like some of the requirement was that you needed something that was not necessarily web-based and still had that same level of granularity. Is that accurate?
More or less, yes. I didn't exactly have a web requirement, and what I found was that the web framework that I had chosen is Pyramid, and Pyramid has a really great native authorization policy in place. But again, the way I got started was by thinking about how to structure permissions using a role-based access control policy. So after I decided on the policy, then I looked for the technology that would enforce it. And I wasn't completely married to using Pyramid, and so I did look at Flask and I did look at Django, and I saw their plugins and what was available. And the thing is, Yosai still offers a very compelling value proposition. Even today, despite what's out there, there are some differentiating parts here that still make it unique, even despite almost 17 years of recreating the wheel across all these different major frameworks. And so a couple of those are Yosai. It's a framework that you can easily customize. It's a security framework. It's fast if you have caching enabled, which you should by default. It offers a granular permission level authorization in such a way that none of these other plugins do. And you can customize that permission further, which I have even for my own personal use. And it can be easily adapted to any kind of application. It's not just for web apps, although the vast majority of the apps that we're creating today are web apps. If people want to use this, say, for like a desktop application, a client that has a client server connection and it's using, let's say, RPC. Well, you could just use Yosai again for that and just write an adapter that knows how to communicate with the server without having to recreate an entire library like this from scratch.
Yeah, the overall approach of having it decoupled from the underlying use case is definitely very valuable, and it's something that I know is a concern that the Python community has started to tackle in the protocol space as well, most notably with the work that Corey Benfield has been doing with HTTP2 and having that completely separated from the actual I/O, whereas in a lot of the other protocol libraries, the I/O and the protocol handling itself have been intermingled, which reduces the ability for reuse within other contexts. So having that capability for security of being able to extract it from the underlying concern and have it purely as a, essentially a protocol implementation is definitely valuable, because it does give you that flexibility of being able to use it in other projects and even for being able to span across projects while still maintaining the underlying security definitions.
Yeah, definitely. It's valuable to take that approach, but it's also reasonable not to, at least initially, because you're trying to solve your own immediate problems and you're not thinking strategically. It was much easier for someone like me to identify a project that had already done it and to port it over than to think from scratch about how I would write or architect such a thing. So I can understand why people didn't take that approach initially, but now such a project like Yosai exists, and it seems like I'm hoping that other people find it useful for that purpose, and it kind of fills a gap, if you will. Addresses a need for something like this, something universal, and I hope to use it in that way. Now, in addition to just what makes Yosai unique, I thought a bit about what kind of people would benefit by using it, and I came up with a few. Teams that have used other types of authorization, such as resource-based ACLs, but they've kind of grown beyond. It's gotten out of their control. It's become cumbersome. It's tedious to manage it the way that they have using groups and so forth. And they've learned about RBAC, and maybe they want to adopt it in another project. Another example is developers who are maybe creating a new type of framework, like yet another web framework, which is very possible because of all the async I/O work that's been going on. Let's say you're one of those leaders in tech, and you haven't even begun to think about how to or what type of middleware to create. Well, you can use Yosai and write an adapter for it. So that's another good candidate. You could be a team that's maybe working on a whole new project, no authorization decisions have been made yet. And, this RBAC thing might interest you. And also, I say finally, if you're part of a team that's using Java today and you're using Apache Shiro, well, Yosai is a port of Apache Shiro, so it's providing functionality that you're familiar with. So you'd be a good fit for this too.
And one of the things that I've experienced a lot for people who come from Java or are trying to copy things from Java is that they get stuck in sort of the idioms of the other language. And so I'm curious as to what your experience was trying to take the underlying concepts from Shiro, but add a Pythonic feel to the overall final product.
This has been quite an exercise. So it was pretty brutal porting thousands of lines of Java code, across like dozens of classes. It's a pretty large project. So it was painful just going through line by line, trying to understand some of the things that were being done. I hadn't been working every single day with Java, so there was a lot of searching involved, and I had to really get acclimated a bit to move forward with each step. But the approach I took was fairly common. My goal was to first make it work, and then I would make it right, and then I would make it fast. So this is a fairly common approach in software development. So what I did was, in the first two versions, was I ported everything over to Python. I refactored some along the way, but starting in the latest version, I really refactored a lot more, re-engineered a lot more, based on feedback, a lot of flack that I had. I'd gone on the first two releases, but people didn't really understand where I was coming from. I didn't share them with them that, hey, I just wanted to make this work initially, and then I would improve it. But it's such a huge project, I couldn't really get my arms around it until that first release. So I did, and I've been doing lots of refactoring and re-engineering since then, and making it fast. The thing is, Yosai already uses caching, and it's pretty quick already. But I've been exploring other ways, for example, using Rust extension to potentially make it even faster. However, on the other side, there are ways to make it quicker, even using PyPy, which I explored as well while working with Rust. So, but overall, when I was porting the project, one of the greatest challenges I had was that I chose to port an unfinished alpha version. So version 1 of Shiro features like many levels of inheritance using mixins, whereas version 2 was it was much more compositional focused, using a compositional design to replace all of that inheritance. And so in version 2, there are far fewer moments of head scratching when you're trying to figure out how code works. The problem that I ran into is that version 2 was unfinished. The main author of Shiro, he's the CTO of a startup, and he wasn't really available to answer questions I had about the new architecture. So it was out there. He said, hey, check this out. Check out version 2. I know you're working on it. And I did, but I was kind of pretty much on my own. I had to figure out what he was thinking and just try to rationalize ways to finish, completing the bridge, if you will, to the other side. And so I ultimately, it was up to me to grab the bull by the horns and finish what was started. And I did. So where it is today is Yosai it works. And many parts are idiomatic Python, and it's pretty fast, but again, it can go a lot further. Another thing about porting Apache Shiro, and probably one of the green lights I had sensed, if you will, when I was reading through it and trying to assess whether I'd be able to do this, was that what made it easier to port it over was that the authors of Shiro had used a solid design, had followed solid design principles. Solid as in the acronym. I don't know if that interests or that rings a bell for you.
Yeah, I'm familiar with the acronym, and I'll add a link in the show notes for somebody who wants to sort of dig into it further.
Okay, sure. We could probably spend an entire hour, a good hour, just talking about how Shiro and Yosai follow the solid design principles. But they do. You might, and if you're familiar with solid, you may understand some of that just by reading through Yosai's code. And a little bit about the refactoring, where you start off, just because you could do something in Python doesn't mean it's right or that it's idiomatic. And it was a learning experience for me. Sometimes I did things knowing that there were better ways to do it in Python, but I just had to get things done. And going back to it and refactoring and reengineering was like, it kind of created a bit of a brain rush for me. I got a bit of a coder's high using it because, or doing that because it felt really good to relieve myself of a lot of this sort of debt with Java. Here are a couple examples. So in Java, you have these if-else conditions everywhere. You have to check a condition before you move forward. Whereas with Python, you use try except blocks. The way that people describe this is it's Java. You look before you leap, whereas in Python, it's easier to ask for forgiveness than permission. So I ported tons of if-else conditions to try except blocks, and so that was and in order to take advantage of using Python. And there are some design patterns that just weren't necessary in Python that came from Java. A couple examples include the builder design pattern. A builder design pattern can be just replaced using keyword args and handling them accordingly in a function. Let's see, custom exceptions. I kind of learned this the hard way. I ended up with way too many custom exceptions, and I didn't take full advantage of the exceptions in the standard library. So I got into a bit of a trouble. People had criticized why I was doing that, and frankly, initially I didn't put much thought into it. I just wanted to make it work, and so I did go back and clean that up a bit, and I did find that most of the exceptions that were customized could be addressed with the exceptions in the standard library. If I only took the time to think a little bit about what was available and how to apply them correctly. And I'd say another Java pattern that wasn't necessary with Python was that in Java you have these POJOs, you have these just plain old Java objects being used to store values, and in Python you don't really need to do that. You don't need classes. You can use these primitive types, like you can use name tuple or dicts to store values and to pass them between functions. And so I did a lot of that in version 0.3. I cleaned up a lot of that and tried to take advantage of what was available in Python. In terms of regrets porting this project, the one thing that really sticks out, if I can go back and change anything, there are probably too many iterations of unit testing. I went through too many iterations. I was too focused early on trying to achieve this sort of maximal unit test coverage when I should have waited for the dust to settle a little bit, so to speak, before actually unit testing. The thing is, I thought good unit test coverage would encourage a lot of people to give Yosai a try, because bad test coverage would steer people away rather quickly. I didn't want to scare people away because there's enough scary parts of this, and at least initially, and I was trying to reduce that a bit. But the thing is, I released 3 times within a year, and there were a lot of changes that had broken tests, and so I was going back and cleaning up and changing tests one too many times. So that was a bit of a waste of time. And so if I can go back and do it again, I would just wait until I would unit test later on.
Yeah, TDD works best when you know where you're going, not when you're trying to figure out what the destination happens to be.
Yeah, I didn't really understand how all the parts worked. I couldn't see the forest from the trees, unfortunately. Anyone who's out there, and if you're porting a project from one language to another, take it easy with the unit testing early on. Wait a bit.
Yeah, when you're doing something like that, it's best to do more outside-in testing, where you start at the outside to make sure, okay, the perimeter of my system works the way that it needs to, and then as you sort of solidify the interior bit by bit, then you can work the tests into a more granular level. Yeah,
it's much easier, and you're probably more likely to not have to break or to fix all those root tests, week by week.
And one of the questions that came out of your description of porting the project is, because of the fact that it does have this other code base that it is using as inspiration, I'm wondering if the intent is for you to track its progress as it continues to evolve, or if the point at which you started work on Yosai was essentially just a forking point where Yosai will have its own destiny separate from wherever Shiro happens to go.
Well, it seems that at this point that the people who are supporting Shiro, primarily, the main author has stepped away. He's a CTO at a company now, so he's more hands off, and other people are still supporting the version 1. And so, because I've really ported version 2, and that's incomplete, and they don't really seem anywhere in the near future ready to turn things over to version 2. This is a fork It's a permanent change, and like I said, I had to fill in a lot of gaps. So Yosai is its own creation now, and really the way that it's going to evolve over time is going to depend entirely based on the feedback from the Python community. I don't intend to look to anything that, I can't unfortunately reference anything that is happening now in Shiro. And it really doesn't make sense to it. Yosai has taken on a life of its own.
And given that authentication and authorization are such broad and difficult problems to solve, and any issues with how it's implemented can potentially lead to significant impact in the projects that are relying on it for security. So I'm wondering, what are some of the techniques that you're using to ensure that there's an appropriate level of quality in Yosai itself for other people to be confident using it to protect their applications?
Yeah, sure. It's a perfectly valid concern. But let me first begin by saying that I have not contracted or a qualified third party to audit Yosai, but welcome anyone out there who meets that criteria to please come in and evaluate the project. Currently, I'm not aware of anyone conducting such an evaluation, but I do believe that a qualified third party audit would be helpful. We could spend at least an hour talking about why I'm comfortable with or confident about Yosai and why anyone else should be confident with it, but let me just touch on a few points here. So regarding authentication, so Yosai facilitates authentication. I didn't roll my own crypto. Yosai uses passlib, the very popular passlib library, for the cryptographic hashing and password verification. How a password is hashed and persisted into long-term storage, it's a far more risk-prone exercise, and it's an exercise that's outside of the scope of Yosai. Yosai queries and verifies credentials against those provided by a user. The moment that a credential is no longer needed, it's cleared from memory. Passwords are stored as byte arrays for this reason. Regarding authorization, a few points. Yosai denies access by default. A user is granted access only when that user is explicitly assigned to a role or assigned permission. Yosai verifies that the roles and permissions from a data store imply the roles and permissions are required to perform an activity. Permissions are queried, not created by Yosai. The permission authorization logic works exactly as that which is implemented in Apache Shiro. There's no functional difference. And that logic, it's been battle tested and it's been adopted by major firms. Regarding sessions are also treated with care. A session ID changes when a user logs in. In web applications, session IDs are stored in cookies, and sessions time out due to inactivity and absolute timeouts. Despite everything I've mentioned and why I'm comfortable with using Yosai, I nonetheless encourage anyone who's interested in adopting it to consider auditing it prior to production use.
And you mentioned, too, the sort of test coverage that you have for it. I know that you said that you have had some trouble with being able to have the tests keep up with the work that you're doing. But at this point, is there a fairly substantial level of coverage on the actual project itself to prevent any regressions from the current state?
With each release, I've tried to achieve maximal test coverage. So when I had shared my grievances about testing, I nonetheless did test. So with each release and in the README, I try to make it very clear about test coverage, and it's, I would consider it's still at a very great level. I'm not trying to achieve 100%, but I'm trying to achieve at least 90% across all the major modules, and so it offers that.
And you alluded to the README briefly, and I know that when I was doing research for this interview, I was digging through the documentation, which I must say is quite substantial and fairly well written. So I'm curious, one, how you managed to achieve that level of coverage of the overall documentation, and two, what sort of inspired you to actually put out that level of effort to make sure that you had that documentation to begin with.
Oh, thank you. I appreciate it. It was weeks of effort, if not months of effort. And, all of that is really above and beyond what I would have ever done if I wasn't open sourcing this and I wanted other people to use it. But because it's such an elaborate system, I felt it necessary to document as thoroughly as I could. And I tried to imagine the questions that people would have, and I tried to put it all together in that webpage. There's a full project page for Yosai. And I try to summarize that in the README, and I try to create visualizations and things like that to, just make it easier for people to understand what's going on. It took a lot of work. There's no way around it. Writing technical documentation wasn't something I've ever enjoyed doing, but I found that anytime you write software that someone other than you is going to use, and if you don't want to be fully roped into everything, you've got to teach them somehow. And so you do that through documentation and tutorials and demos. And I created all of that for Yosai because, I've already moved on to other projects and I want people to find it useful. So I saw no other way.
And so it sounds like you did all of that yourself. You didn't hire a technical writer to farm any of that out.
Yeah, that's all me. Whatever it is in my life, I figure things out. I guess my greatest strength is that I guess I eventually can solve most of the problems thrown at me, and I'm willing to give it a try, as anxiety-inducing as it really is. I've written all the documentation. I did manage to copy, however, some of it from the original Apache Shiro website. I copied some of it, but I really try to paraphrase, and I really try to make things unique. I don't like copying other people's work. I do sometimes when I get absolutely lazy, but then when I do, I try to cite, the original author as best I can. I'm not trying to get credit for stuff like this, so I do believe in giving credit where credit's due. But I did a lot of it on my own, with the help with static site generators. I used Hugo. I used the Hugo static site generator, which is written in Go. I tried the ones written in Python, and I tried Jekyll, but I found Hugo and the templates that were available most useful. To create the documentation, I used a Python library called mkdocs. I used mkdocs. It was actually great because I didn't have to do hardly anything other than write Markdown, and the static site created all the documents for me, and it did it very nicely. However, I also used, for the tutorial, I used Hugo. But that was only to create the time-based one-time passwords tutorial. So you're going to see some difference, but the general idea is to write your content in Markdown and then find a static site generator that will convert that Markdown into a presentable web page. And
there's certainly no shortage of options on that front, having explored a number of them myself for various other use cases, both for blogging and for different projects I've been involved with.
It's great.
So I'm wondering if you can dig a bit into the way that Yosai itself is architected.
Essentially, you install Yosai and its extensions from PyPy, and then you configure this YAML settings file. During your application's initialization process, during the bootstrap process, what you want to do is instantiate a Yosai instance, telling it the location of that settings file. And then you store that Yosai instance somewhere that it's accessible during every application call that may require Yosai-related functionality. If you're building a web application, what I'm talking about is the registry that your middleware references. The next step is you write a piece of middleware that opens a context using the Yosai instance as a parameter. And that's the only thing that the middleware needs to do, is it opens up a context. Now, from that point on, wherever we want to authenticate or manage session state, what we do is we create a subject object, and we use it to log in a user or access the user's session. And the main API, Yosai's main API for your typical developer, it's accessible through this subject object. And the next thing is, so you use the subject object to authenticate and to manage session state. You could also use it for authorization, but you don't necessarily need to. So let me explain. Wherever you want to authorize access, you have two options. You can use imperative style access control or declarative style. Imperative, you're creating a subject instance and you're making explicit calls to the subject's authorization API. With a declarative style access control, you're decorating functions with authorization logic and allowing Yosai to handle all that boilerplate authorization logic for you. If anyone's interested about how this works in detail, please go to the documentation on the project website, and you're going to see exactly what I'm talking about. But this is how Yosai works in a nutshell. You create the instance, you put it somewhere, you open up a context, and from that point, you could use Yosai for authentication, authorization, and session management.
And when you're not using Yosai as part of a web application, which is where I, in particular, am most familiar with managing access control, I'm wondering what are some of the other types of situations where a user should consider integrating that authentication and authorization capability into their project?
It's kind of a cop-out, but when you write an application where user identity matters and you want to control what that user can do, then your application would benefit by Yosai. The example that I had raised earlier is another viable example. It's an old sort of client-server app, setup, except you've got like maybe a thick client application, and the server doesn't necessarily have to be a web server. Maybe you're using RPC, but you would still you still need to know who's making the calls, who the user is, and you want to control what that user can do.
Yeah, another type of example that somebody might use is a sort of IoT situation where you've got a sensor that wants to be able to send information to a backend, but you want to make sure that people can't just spam the backend with arbitrary false information. So you need to have some method of authenticating that sensor to the backend and controlling the types of information that it's allowed to send based on, a unit ID or something like that.
Oh yeah, absolutely, and we're just warming up. And I mean, when we talk about IoT, if people are running home servers and people are trying to access, physical locations, trying to open doors and so forth, well, that server is going to have to know who that person is that's trying to enter, and there's going to be access control, involved. So yeah, if it might be a web application that's doing that, it may not be. It might be something else. And if you're writing in Python, hey, maybe you should use Yosai for it.
So what have been some of the most challenging aspects of building Yosai, and what are some of the things that you learned that you weren't expecting to come across in the process?
Yeah, well, I touched on some of that already. The whole project was very challenging, but it was a huge learning opportunity for me. I was really cutting my teeth on a huge project with this. Cutting my teeth with Python, and there were a lot of moving parts and so forth. So it was the sheer. It's just a ginormous effort, so I would say it wasn't any individual thing that was making it hard. It was just all of them combined. Writing the documentation was really hard. So let's just leave it at that. The docs were the hardest, yes. So please read them.
Well, I have read I've read a fair bit of them, so you've got at least one person who's benefited from them. So
you've made it all worthwhile. Thank you. Yeah.
And are there any sort of unexpected use cases that you've seen people put Yosai to that you would like to call out?
Not yet. None that I'm aware of yet.
So it sounds like the sort of most valuable community contribution you could have right now is just having people use it and provide feedback from their experiences.
Oh yes, absolutely. Give it a try. If you want to write adapters for any of your existing frameworks, I would help you do it. I guarantee you that together we would have it written and tested within just a few hours. I haven't done it because it's not something I want to own and manage going forward, because I'm probably not going to use it unless it's for Pyramid, and I've already released the Pyramid adapter if you want to see how I did it. But because I would like to see people use it, and I would value your feedback, I'll help you. I'll facilitate this by showing you how to write it.
And you mentioned that one of the approaches that you've taken to try and speed up parts of Yosai is to actually write a Rust extension for it. So I'm wondering if you can just spend a bit of time talking about your experience with that, particularly given that Rust as a extension mechanism isn't fully supported by core Python yet.
But the thing is, it's really picking up steam. Since the beginning of this year, things have really been moving quickly on the Rust front. So early this year, I read a blog post by Armin Rocher about extending Python with Rust. He wrote about his experience, and then he open sourced his work. This inspired me to give Rust a try. So I spent a few weeks learning the basics of Rust, asking a lot of questions on IRC, and I learned how to write a Python Rust extension. I thought, what better way to learn it than with a practical use case? And so what I did was I chose the part of Yosai for authorization that had the potential to become more computationally expensive, because if you're going to write something in Rust, and ideally you want it to run faster. So I thought, well, this part of code would benefit by that, and so I ported that entire small library for authorization, and the end result is I managed to port all of it. It works in Rust. I got to learn some Rust. I open sourced the work, and I even wrote a tutorial about it. But the thing is, I haven't given a talk about how to extend Python applications with Rust, and I might in the near future, especially now because there's some other really interesting things happening on the Rust front with respects to integrating with Python. Two projects that come to mind are Pythonium trioxide, which is Pi03. The author just made his first release on that a week ago. It's one way to write Python extensions. Python Rust extensions, and it's a two-way sort of library. So if you want to access Python from Rust, you could do it, or you could access Rust from Python. His library allows something like that. And Armin Rocher, since that first project, learned from his experiences and has created an even better way to extend Python with Rust. And he's calling that Snake, but spelled a little differently, SNAK. And I've had some correspondence with Armin, and he's still fleshing some things out, making some important decisions about things such as memory management. But I think that with all these, there's a lot of interest, and there are a lot of people who seem to be working on ways to extend Python with Rust, and I wanted to give that a try, and so I did. And of course, at the end of this, I really want to know, how much faster is this Rust version of what I wrote in Python? And so I tried as best I could to come up with an apples to apples comparison, just running the exact logic on both parts and trying to eliminate any other overhead. And what I found was that, unsurprisingly, the Rust ran approximately, let's say, 10 times faster than CPython. But here's the thing. Then I want to know, what happens if I run this through PyPy? And so I did. And the PyPy, the compiled Python, actually ran faster than the Rust extension. And I was like, my mind was just blown away when I saw it. I was like, wow, this is great. This code would actually benefit by using PyPy. Why would I do this in Rust? But the thing is, I wouldn't have known that unless I went through this whole exercise. So that was revealing for me from this experience.
Yeah, it's definitely interesting. And if you are looking for a venue to talk about any of your work, I don't know if you are aware, but the call for proposals for PyCon Canada and PyCascades are open right now. So.
Okay, noted. Yeah, I would love to share my experience with this. Maybe elaborate on this story too.
And what do you have planned for the future of Yosai? I know that you mentioned that you're not actively working on it at the moment because your attention is elsewhere, but it sounds like you're still committed to maintaining it and supporting it going forward. So I'm wondering if there are any sort of additional features that you're looking to implement or would like other people to help you with adding in.
Yes, absolutely. So I think that Yosai would benefit by more refactoring and reengineering and trying to make it even more Pythonic. It's a great experience trimming off the fat. It's a great experience making code more efficient. And I think Yosai still has rooms for improvement. And so there's that. And I usually do bits and pieces of that with each release. But if anyone would like to give it a try, read through the source and see what you can come up with. I would gladly approve of changes as long as you're not breaking anything. What I plan to do, at least in the very next version, which I expect to have done by the end of this year, hopefully, is I've already written support changes on the master branch to support the Rust extension. I plan to modularize Yosai so that if people just want to use the authorization component, they can without having to install all of Yosai and all of his other parts. So modularization is another project that I plan to accomplish, and I want to make sure that each of the parts work through PyPy. Another thing is I'd like to add support for JSON web tokens. I'm very cautious about using JWT because of the experiences other people have had. So I'm still looking and researching how to follow best practices, and I'm really receptive to people who have had experience with JWT, and I may be interested in making that work with Yosai.
All right. Yeah, I've actually got a blog post on my blog about my experience using it a couple of years ago, but I'm sure that the overall best practice has been updated since then.
I'll check it out.
So are there any other topics that you think we should cover before we start to close out the show?
I've covered a lot of things here. I think this is a good start, but I encourage people to check out the GitHub repo and to check out the project webpage.
And for anybody who wants to contact you directly or follow the work that you're up to, I'll have you add your preferred contact information to the show notes.
Sure.
And with that, I'll bring us to the picks. And my pick this week is the Brains On podcast, which is a show that I started listening to with my kids recently, which is a podcast from one of the NPR stations that is a science show focused at kids in the, probably 8 to 14 time range. And it's just a lot of fun to listen to. So some of the shows we've listened to are things like how the moon affects the tides, debates between the deep sea and deep space as far as what is cooler. So just surfacing a lot of interesting content about that, and fire versus lasers. So it's just a fun show with a lot of whimsy and a lot of really valuable educational content. And with that, I'll pass it to you. What do you have for us for picks this week?
So what I'm picking is a really great project. You can see it out on GitHub. It's called Asphalt. It's the Asphalt framework. Asphalt is an async IO based micro framework for network-oriented applications. It's written by Alex Gronholm, and he spends a lot of time creating Python software correctly, making sure it's idiomatic. And Alex has been very focused on using the latest and greatest from the async IO front. And I'm very optimistic about where this project is going, and I encourage people to check out Asphalt.
All right. And as a meta comment here, are there any of your own projects that you'd like to call out or try and get people interested in?
Well, I'm now working on my own venture. I was working in financial services for almost 10 years, and it's all part of why I was learning Python and why I'm building Yosai and all these other projects. I am working on something, and it's been pretty lonely, but I've been trying to just get the work done as a solo founder, and it's really out of necessity. So I'm an entrepreneur who's an avid contributor to the Python community, and I'd love to network with people and connect with people and share with them what I'm working on. This is not a place, for me to do it. I didn't want to take advantage of our discussion, but it's what I'm very passionate about. It's what's driving me to do what I'm doing. So it's a major part of my life, and I love to talk about it.
So I'd like to say thank you for taking the time out of your day to share your experience of working on Yosai and porting it from the Shira project. Definitely looks like an interesting library, and one that I plan to take advantage of in any future projects that I work on that require that authentication and authorization capability, because it looks to be fairly comprehensive and flexible. So I appreciate that, and I hope you enjoy the rest of your day.
Thanks, Tobias. Bye, everyone.